Hello and welcome to the section of the tutorial, and what we're going to do now is a really interesting cool section, and that is teaching you how to use this calculator to graph polar coordinate or equations that are in polar coordinates. So we've already got a lot of experience with this, and in regular functions we go into the Y menu and we put our functions in here, and then we just hop on over to the graph, and then it's plotted, and then we can use the zoom functions to zoom in and out and set the axes, tick marks, and all that stuff in the window menu, and we're pretty good at that, and we've done that a lot. And so what you're going to find is that when you do this process for polar equations, polar coordinate equations, that it's really the same exact thing. It's just that you're defining your equation differently. So what you need to do is first go into the mode menu, and I always prefer to work in radians, but we might switch back and forth during the tutorial here. Go over here, and right now we're in function mode, which is regular graphing mode. This entry is for parametric equations. This function, this little selection here, is for polar equations, and this guy is for sequences. So we've really only got one more category to cover, and that's polar equations. So we go ahead and enable that, and we get out of here. And then in order to enter our equation, which is always the first step, we go to the y equals menu. And notice that it's a little bit different now. It's not y equals because we don't have x and y coordinates at all when we talk about polar equations. Instead of x and y, we have r and theta. And just as a reminder to you, you should learn this in your class, or if you're watching my DVDs, you can learn it there too. And that is, that here, your equations in polar coordinates, if you think about it, you have a little xy graph plane just like you do before, but your equations are going to be, instead of y is equal to some function of x, here your equations are all going to be r, the radius of in the xy plane, or in the coordinate plane, is a function of theta. So you're always going to start theta over here off the x-axis, and as theta increases, your radius is going to change. So it's basically like being a function of x, except in this case it's going to be a function of theta, which is the angle. So here you have 6 different equations you can plot at once, and just like before, you can change what some of these look like. You can change the line from that to a darker shaded line, and you have some other options here that we've talked about previously. For now, let's just leave them all the same. And so the first step is for you to go ahead and put something in. So let's put something like 1 minus the sine of, and hit this button, and you will find out that theta pops up. So this button is a multifunction button. When you're dealing with irregular functions and you hit this button, x pops up. When you're talking about polar equations and you hit this button, theta is going to pop up. When you're dealing with parametric equations in the last section, t pops up, and when you're talking about sequences, n pops up. So whatever equation you type in, this is the button that you're going to use, is really the bottom line. So now we have a guy set up. Let's go over to graph and just see what happens. Well, obviously we've already zoomed in from a previous section, so let me go zoom standard number 6, and you see the graph is here in the center. So let's go back to the zoom menu. Let's choose Z box, and then we'll go over here and we'll just zoom in. So basically all of your knowledge that we've learned in the previous parts of the course is going to directly apply to polar equations and graphing. So it's not a huge difference. Let me go ahead and hit enter. Okay, a couple things I want to point out. I can hit trace here. Now notice as I trace that I've got x and y coordinates down here. And these are literally the x and y coordinates of the point as it moves, but that's not terribly helpful to me because this is a polar equation. So my recommendation to you is every time you start plotting a polar equation, go into the format menu right here, and the very first thing here, right now it's telling me that when the trace coordinates, when I trace on a graph, is coming back in rectangular form. It should really be coming back in polar form, in my opinion. It's going to be a little bit more intuitive because that's what you're usually looking at. So let's start the trace again, and notice that it's a lot better. Let's go back over here and let's go to theta of 0 again. So here we are in the axis here. This is an angle of 0 is what it's telling me, and the radius is 1. So this is a radius of 1 away from the center. As I increase the angle, like this, the angle is increasing 0.524 radians, 0.654 radians, 0.785 radians, etc., etc. As I increase, the radius is changing. So as the angle is going like this way towards the y-axis here, the radius is getting shrinking and shrinking and shrinking, and that's pulling the graph in like this, like the little heart that you see. And as you get here, the radius gets to 0, so it comes back into the coordinate origin, and as the angle moves past that point, I'm getting bigger and bigger and bigger. So that's basically it. This is the angle in radians, and this is, as you continue on past, this is your radius that's happening, and you draw that nice heart. Now you have full use of all of your zoom commands that we've talked about before. ZBox, you can zoom in, zoom out, and all these things. Now one that's nice that you might want to play around with is Z squared. This is not a square screen. So, and because of that, when you draw circular figures or things that look kind of like circles, which a lot of the trig functions are going to do in polar form, then they're going to look a little bit squished. You see how this is sort of flattened like a pancake like this? You can sort of tell that it's a heart, but it's kind of squished. If that bothers you, you can go and hit Z squared, number 5. And now it's looking a lot more like a real circular figure. And so, it doesn't change anything. The trace values don't change. Nothing changes. It's just behind the scenes adjusted basically adjusted all of this stuff, the window boundaries for X and Y, to make it look more like a circular figure. Which brings me to the window menu. You can adjust all of these things like you normally do. Right now, our theta min, it starts at 0, so we started at an angle of 0 radians. And theta max is going to default to this number here, 6.28, is just 2 pi radians. So in terms of a circle, this is pi radians over here, and if you keep going around again, it goes to 2 pi radians. So in the window menu, theta max is basically going to stop after 1 revolution, which is usually fine for most cases, but you could change it if you want to. Theta step is the distance between, in your plot, it's the distance between points in theta. And then the X and Y values here down below behave just like in the rectangular sense. It's changing the tick marks along the axis. So it's going to change how the graph looks. So whether or not you go here or whether you go to Z standard, the graph is the same. It just looks a little bit different, just like the zoom level looks a little bit different. You can also go in down below to zoom fit 0, and it should blow it up for us. And it's going to completely fill the screen and make this plot as large as it can possibly be. You can still trace it, and you can still do all of the other things associated with it. Now, I want to show you another thing. You can plot more than one function here. That's no problem. You can do that just like you can do, in rectangular mode. So you could plot, let's say, cosine of theta, right, for the second guy. Go back to the graph menu and let's see what this looks like. Now this is a little bit off screen, so let's go back into the zoom and let's go over here to zoom fit 0, and let's see if it's smart enough to expand our zoom so we can see both of those guys. And we can see the other one is like a circular looking thing over here. And if we really want to get fancy, we can go to Z square, which is 5. And it's going to make the screen sort of behave as if it were a square screen. So you see this is looking like a circle now. It hasn't changed anything as far as the trace goes, but the look of it looks different. So right now I'm tracing along the graph that I was on before. I'll hit the down arrow, and then I'll be tracing along the other graph that I've plotted. And you'll see, let's go back over here to theta of 0. So when theta is 0, actually let me show you another trick just to make this clear. Let me go to y equals, and we'll temporarily turn off this first graph. You can highlight the equal sign, hit enter. So you don't have to delete the thing, just turn that off, go back to the graph menu, and now it's gone. So it helps us. Going back to trace, when theta is 0, which is on this axis, radius is 1. As I go this way and increase the radian angle, as I increase this angle, the radius is going up and up and up like that, and then it goes down closer and closer to the origin. So as the angle gets bigger like this, the radius is getting smaller and smaller and smaller and smaller according to this equation, because I'm taking the cosine. And so here at this angle, which is hard to see in terms of a decimal, but this is pi over 2 radians, which is the angle up here as you travel this way. The radius is 0, so it's pulled the graph back into 0. And as you continue past that point, the radius goes this way and so on. And the radius is showing negative here, and that's just because the radius is extended down below the axis rather than above the axis. All right, let's go back in here, and let's go and turn this back on, and go back to graph here. Now, you have the same capabilities to look at this guy in terms of a table, just like we did for functions. So first, let's go to table set and see how the table is set up. Right now, we're going to start off at 0. Our increment is 1 for theta. For theta. And everything's automatically done. So let's just go and see what table is generated. So here we have our two functions, R1 and R2. Theta is increasing from 0 radians up to 6, 6 and so on. And here we've got different values here that we can scroll through and look for each function. So it's a nice little way to do a tabular thing. Now, if you go back into table set, and the reason that it was kind of the table was kind of small is because right here I have the table set of 1 here, a delta of 1. So that means that when I go look at the table here, the distance between angles here is just 1 radian, which is a very large thing, because remember, 2 pi radians all the way around the circle is only like 6.2 radians or something like that. So it's in polar form, it's probably going to pay off to go into table set here. Let's do 0.1 as a delta. So we'll go back into table and we'll see that radian measure is increasing a lot more gradually, and so we can scroll down and really see how this thing is behaving and look at all the values here for the two different functions. So different angles, you get different radii that would end up being plotted if when we go off and look at the function. Now let's go back into table set and let's change this from auto for the independent variable, which is theta, to ask. So let's hit that. Let's go back into table mode, and now the table's blank, just like we would expect. So now we get to input our values and create a user-defined table if we want. So let's say I want to know what's going on exactly at 4.5 radians. So with 4.5 radians, I get the two values of my function. What about 3.66 radians? And so on and so on. What about negative 0.2 radians? Which is just an angle going in the other direction. So you can type in anything you want. It's a great way if you have a couple of different functions. If you're trying to calculate, values for two different functions at once, it's much faster to put it in here and use the table functions than it is just to go back out to the calculator blank screen and start trying to calculate cosine of things and just really doing it manually. It can save you a tremendous amount of time. Now, I also like to tell you that, when you're looking at a graph like this, you can do just what we've already done in the function. When we're doing functions, you can save this guy and come back to it later. So you could go into the draw menu, and you have to go over to store, just like we did before, and you can store. Now, you don't want to store it as a picture, because if you store it as a picture, you won't be able to interact with the graph. It'll just be like an image. So go to store graph database, and it's going to ask you for a number, 0 to 9. So go ahead and hit 1, just as a number. It's done. Now, just to make sure we understand, let's go and clear the equations out of here just to show you what's really happening. We go back to our graph. Nothing is there because we've cleared it out. Now, 2 days later or so, we get home and we want to pull these graphs back up. We can go to recall graph database, number 4, and we can type number 1, and it says done. And at this point, our equations are back in the same place they were here, and our graphs are working exactly how they were before, and they're completely interactive. I can trace them. I can do everything I can do with them before. So if you ever have a need to store something, go ahead and store it as a graph database. The only time you ever wouldn't is if you had to store it as a picture, is if you actually put some drawings on the graph, like you can draw the line segments and stuff like that. If you ever did something like that, then you'd have to store it as a picture, a non-interactive picture. But we didn't do that, so we can just go ahead and do that this way, which is much, much better. Now, one more thing I will tell you is if you go into the mode menu, we did this for functions also. If you go down here and go over here, you can display a graph and a table at the same time, just like we did for functions. So now when we go back to the graph menu, we will see our function. It looks a little squished because it's over here, but it's here. We can also see our user-defined table here. Now we can go into table set and change this back to auto. right? And now when we go back, everything's automatically generated. So it's a great way. I can hit second function table, so I can start scrolling here. So I can sort of look at my graph and look at a table of the values at the same time. And if I want to look at R2, I just go over to the right and I can see everything there. So it's a nice way to get a good visual representation of what is a picture of the graph doing. At the same time, I can sort of look at the values. And another thing you can do is you can go down here. Instead of full screen, you can change it to horizontal mode. And so now you see your graphs on top, right? And you see your functions directly underneath. So if you wanted to make a quick change, like if you wanted to go here and say, well, what would happen if I put this guy and then I squared this function, or raised it to the -1 power or something like that? What exactly would that do? So you could make little changes here, and then you could see what happens interactively at the top. It's not very interesting here because I'm zoomed in at the wrong level, but you get the point. You can make little changes and you can sort of see what's happening. So we'll go into the mode menu and we'll put ourselves back in full screen mode, which is most of the time where you're going to want to operate. Now, another thing you can do is when you're looking at this graph here, let's go back and fix our little equation here because that's not terribly interesting what was going on. Let me go back up here and just hit delete key, get rid of that, and we should just verify that our graph is back where we expect it. Okay, now we can go into the calculate menu, which is a great way to find an exact value. Now, you know, whenever you're doing your tracing on your graph, you can get an idea for values, but you're kind of limited by, you know, as you go here and you trace and you start tabbing over, theta is changing by that step that we defined before. But what if you wanted to look at theta of 1.5 exactly? Well, then you may not land on that, so it's difficult. But you can go into the trace menu and you can say calculate value. And then it's going to ask you for a value of theta. You can put exactly 1.5 if you wanted to, and it will calculate that value at 1.5. The radius is 3, according to this equation here that we've defined. So you can also go back to the calc menu. You know, what if you wanted to look at a value of 2.3 exactly? Then it would go in and calculate that and tell you that at an angle of 2.3, the radius is 2.54. And it'll do its best to show you roughly on the graph where that is. So it's a great way to calculate individual values. You can also use the table for this function, but it's just, you know, different ways to do different things. Now, also within the calc menu, you'll see that you can calculate these basic derivatives. You can, dy dx is somewhat useful here. It's going to be converting back to rectangular form to do that for you. Most of the time, you'll just want to calculate dr with respect to theta because this is a polar equation. So you'll hit this guy, and you can take it over to wherever you want on your graph here, you see, and just hit enter, and it will calculate dr d theta, which is the change in r with respect to theta. So if you were to look at this function here and take the derivative of this with respect to theta and then plug in the value of r that you want, you would get the answer. And if you go back into the calc menu, you'll see that it also gives you an opportunity to calculate dy dx. That's a little bit misleading because this is a graph in terms of r and theta, but basically behind the scenes, if I hit this guy here, the calculator is going to convert to rectangular form and then give me a slope of the tangent line dy dx there as if it were a rectangular graph, even though it's not. So that's not going to be that useful. You probably won't do that very much if you have a polar equation, but this guy's really useful. Number 3, you might use it all the time. And certainly number 1 is extremely useful too. So that is a good primer on how to use this calculator to plot polar equations. Basically, you have 6 equations you can put in at once. You're defining everything in terms of theta because that's what a polar equation is. You can graph them and put them on the same axes. You have the same access to zoom tools as before. The window menu behaves the same as before. Basically, you can change the x values and so on to shrink your window, etc. Or you can use the zoom commands to do the same thing. Theta max is the maximum angle it's going to look at, which is 1 full circle, 1 full revolution. You can also look at any of these guys in terms of a table, and you can set this table up in the table set menu just like we've done before. You can change this guy to ask, and then that's going to allow you to have a user-defined table that you can type in values for. You can take these graphs here and you can store them by going into the draw menu and going to the store guy here and do store and recall graph database. And when you recall them, it'll be completely interactive. So it's a great way to save your work for later. So it's a good introduction to doing this guy. Play with it, put different equations in. When you're doing polar equations, they're really pretty if you put different trigonometric functions in. So have fun, multiply them together, divide them, whatever, and just look at it and play with it and trace those functions. And you can learn a great deal about math just by playing with your calculator.